So, let's talk about building muscle on a low-carb diet. You've probably heard a million times that it's impossible, that you need carbs to grow. Well, we're going to dive deep into what the science at the cellular level actually says. And I think you'll be surprised to learn why it's far less dependent on carbs than you think, and why knowing this might just be a game changer for your long-term health. Let's get right into it.
Okay, let's just cut right to the chase with the most actionable piece of info. After your workout, a meal with enough protein to get you about 2 to 3 grams of an amino acid called leucine, that's pretty much all you need to max out the muscle-building signal. Yeah, forget pounding a sugary drink to spike your insulin. The real work is being done by the protein and the workout itself. We're about to see exactly why.
Now, I know what you're thinking. That goes against everything we've been told, right? Insulin is the most anabolic hormone. You have to have carbs to build muscle. It's a really compelling story. But you know what? It's really only a half-truth. Carbs can help, for sure. But are they absolutely required? When you look at the actual molecular machinery inside the cell, the real story is so much more fascinating.
So, to get to that real story, we have to look inside your muscle cells at the master growth switch. There's one central command center that controls this whole process, and once you understand how to flip it, everything else makes sense.
And that switch is called mTORC1. That's pronounced mTORC1. And yeah, it stands for the crazy mouthful, the mechanistic target of rapamycin complex 1. But don't worry about that. All you really need to know is this. mTORC1 is the boss. It's the one that tells your cells, okay, stop breaking things down for fuel and start building new muscle tissue. So, the billion-dollar question is, what flips the switch on?
Well, it turns out there are 3 main inputs. First, the actual physical force from lifting weights. We call that mechanical tension. Second, the presence of that key amino acid we just talked about, leucine. And third, you need a little bit of insulin in the background, but way less than you've probably been led to believe. Let's break each of these down.
First up is pure physics. When you lift something heavy, that tension literally creates a specific signaling molecule right there at the muscle cell membrane, and that molecule talks directly to mTORC1. It's a direct mechanical to biochemical signal. No food needed for this part. The barbell is literally having a conversation with your muscle-building machinery.
Okay, second, your cells are smart. They're not going to start a big, energy-expensive construction project without knowing if the building blocks, the amino acids, are actually there. And the main way it checks for that is by sensing for leucine. It isn't checking your blood sugar, it's looking for leucine. That 2 to 3 grams we mentioned, that's the magic number to let mTORC1 know, hey, the bricks are here, it's safe to start building.
And third, we have insulin. Now, yes, it has a role, but it's not the main character. It's more of a supporting actor. And this is the part that blows people's minds. Look at how little you actually need. Just 5 to 10 microunits per milliliter. That's a tiny amount you can easily get just from eating a protein-rich meal. Insulin's job here is just to give a permissive green light, not to floor the accelerator.
And this quote just says it all perfectly. The entire system, the whole shebang, is engineered to respond to mechanical load and the availability of amino acids, especially leucine. It is not, primarily, a glucose-sensing system. So when you hear that low insulin is going to kill your gains, you're hearing someone confuse a simple permission slip with the actual main driver of the process.
Okay, let's address the elephant in the room, because this is the strongest counter-argument. What about muscle glycogen? Right? If you're not eating carbs, your muscle's fuel tanks are going to be lower. Can you even train hard enough to create that all-important mechanical tension? It's a fair question, so let's tackle it head-on.
And look, the pro-carb argument is absolutely right about this. Glycogen, that's just stored carbohydrate in your muscle, is without a doubt the top-tier fuel for really intense, high-volume workouts. Nobody's debating that. The real question is, how much do you truly need to get the job done?
So this chart, which is based on some classic research, shows what happens after a few weeks on a strict ketogenic diet. And yeah, muscle glycogen drops quite a bit, down to about half of what it would be on a high-carb diet. So that's a real reduction. It doesn't disappear, but it's definitely lower. So what does this mean for you in the gym? Well, for most of us, doing focused, moderate volume training, you can absolutely generate a powerful enough signal to build muscle, even with lower glycogen. That mTOR switch cares about the intensity of the tension, not just the total amount of work you do. Now, if you're a serious athlete training with super high volume multiple times a day, that's when strategically adding carbs to top off your glycogen becomes a much more useful tool. All right, now I want you to pull the camera way back with me, because this is where the conversation gets so much bigger than just the gym. This isn't just about building bigger biceps, this is actually about how you age.
The data on this is, well, it's about as crystal clear as medical science gets. Having low muscle mass as you get older is one of the single strongest predictors of dying from any cause. Your muscle is your metabolic armor. Keeping it strong into your 60s, 70s, and 80s isn't vanity. It is one of the most powerful things you can do for your longevity.
But here is the massive paradox. That same mTORC1 pathway, the one we desperately need to build that protective muscle, is also linked to speeding up the aging process if it's just left switched on all the time, from constant eating and high insulin. It's a wild idea, right? The very on switch for growth, when it gets stuck in the on position, can actually wear out our cellular machinery faster. So this leads to this really powerful idea called temporal partitioning. The goal isn't to kill mTOR forever, of course not. It's to cycle between two different states, an mTOR-dominant build mode right after your training, and then an AMPK-dominant repair mode for the other 22 hours of the day. You can think of AMPK as the opposing switch that kicks off cellular cleanup and deep maintenance. And this brings us to what might be the most important question of this whole explainer. What if the best strategy for lifelong health is to figure out how to build and maintain our muscle in a way that keeps our baseline insulin low? What if cycling between building up and cleaning up is profoundly healthier than just being stuck in build mode 24/7?
Okay, let's bring this all home and turn it into a game plan that you can actually use.
So let's recap. The real heavy hitters for muscle growth are the tension from lifting and the leucine you get from protein. Insulin, its role is just to give a quiet thumbs up, not to be the star of the show. And for most of us, we have plenty of glycogen to train hard and effectively. And maybe the biggest idea of all is to think about cycling. Have a dedicated build window around your workout, and then let your body shift into a repair state for the rest of the time. That cycle might just be the key to being both strong and healthy for a very long time.
Hey, if you enjoyed this deep dive and found it useful, please do me a favor and hit that like button and subscribe to the channel, Adam Explains. It honestly helps a ton. And if you have any ideas for other topics you'd like to see me break down, please drop them in the comments below. Thanks so much for watching.